All right, the next graph we're going to look at in section 8.2 is a cardioid. So this is going to be a heart-shaped graph. Now, look at the general equations for this cardioid right here. It's going to look like this. A parentheses 1 plus or minus cosine theta. If I distribute that A, it's A plus or minus A cosine theta or A plus or minus A sine theta. So right here, these two numbers must match in order for this to come out to be a heart-shaped graph. So if I look here, I've already got my cardioid word written. And we've got our equation for number 2, 4 plus 4 cosine theta. So these two 4's match, which makes this thing become a cardioid. Now we're going to do this very similar to how we did the circle in problem number 1. So I'm going to go 2y equals, I'm going to type my equation in right here, which is 4 plus 4 cosine theta. Remember, hit that X button to get you that theta, and then I'm going to go to my table. Now remember, I'm going to go back and make sure you got this set up right here. Your table set should start at 0, it should increment by 15, and it should be on auto. So when I go to my table, I'm starting at 0. So using my table to get these values right here. Remember, we're rounding to the nearest tenth. So when we round to the nearest tenth, we're just rounding to 1 decimal place to get us to our solution. All right, so here we go. At 0, we've got 8. At 15, we've got 7.9. Be careful there. At 30, we've got 7.5. At 45, we've got 6.8. At 60, we're at 6. At 75, we're just 5.0, so I'm just going to call that 5. And at 90, we're back to 4. So that's the first quadrant. All right, I'm going to scroll, and I'm going to start at my 105 right here. So that gives me, if I round to 1 decimal place, this 6 is going to bump that up, so that's back to a 3. Then I've got 2. Next one I've got is 1.2. Then I've got 0.5. That 3 is not going to do nothing, so I'm going to call that 0.5. Then I've got 0.1. You can see it's getting smaller right here. And then I'm back to 0 at 180. All right, so I'm going to scroll up to start with my 195. And at 195, I'm back to 0.1. You see symmetry going on now. 0.5, 1.2, 2. There's that 3 because it bumps it up. 4, and 5. And I'm back to 300 right now. So scooting up to give me my 300. All right, so this is 6. Then I've got 6.8. You see your numbers matching up there. You've got 7.5. Then we've got 7.9. And then at 360, we're back to 8. So that's how my chart got set up for that problem. Now, what I'm going to do next is I'm going to take each of these thetas and radiuses and graph them over here on my cardioid. All right, so let's see what this looks like right here. All right, first thing we got 0, 8. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8. Yep, it fits, but it's all the way out here to the end. At 15 degrees, we've got 7.9. So here's 15. Now, if this was 8, 7.9 is going to be right there before it. At 30, here's 30. We've got 7.5. Remember, this was 8, so this is 7. So 7.5 is going to be halfway. You see it's starting to curve right here. At 45 degrees, we're at 6.8. If you have to keep going back from the original part, that is perfectly fine. So 6.8 is really close to 7. At 60, we're at 6. At 75, we're at 5, so it's starting to curve in real tight now. At 90, we're back to 4. All right, so that's the first quadrant. At 105, we're going to 3. At 120, we're going to 2, so we're just going in as we go. At 135, we're at 1.2, so barely above 1. At 150, we're at 0.5, so be careful right here. Here's 150, so it's barely sitting right there at that point. At 165, we're at 0.1, so that's really squeezing in right here. And then at 180, we're back to 0. So you kind of see how it made that first shape right there. All right, so we got to do the other side right here. At 195, we're at 0.1. So here's 195, so it should match this one right there beside it. At 210, we're at 0.5, so we barely go out. At 225, we're at 1.2. At 240, we're at 2. 255, we're at 3. This is where we start getting back out here. At 270, we're at 4. At 285, we're at 5. At 300, we're at 6. If you have to start back over from the beginning, that's perfectly fine. At 315, we're at 6.8. At 330, we're at 7.5. And at 345, we're at 7.9. 360, same thing as 0, we're back to 8. So if we graph this and connect our dots, curve it as we go. It's not going to be straight lines because remember, we're working polar coordinates. Don't forget that 0, 0 point was also a point on this plane that we also have to graph. So there's my cardioid. So as you can see, it's similar to a circle, but it kind of caves in to make the shape of a heart, so a heart-shaped graph. And that happens when these two numbers match right here. Now remember we talked about before being on the x-axis or the y-axis. Anything that's cosine is going to be on my x-axis. If it was negative, it'd flip over here. Anything that had sine on it would be up or down on my y-axis. So these two numbers must match to get me a cardioid. Now, let me show you some examples of what cardioids can look like. So here's one example of a cardioid right here. This happens to be just an apple. You can see your little cardioid right here where it kind of starts at that 0, 0 spot right there. All right, this happens to be another cardioid right here, but we're looking at the base of this snowman right here. The base of this snowman makes the cardioid of that problem right here. All right, here's another example of a cardioid. It's the balloon of the cardioid. So this right here, it was 1 plus sine theta, so it landed on my y-axis. So the balloon is the cardioid. Here's another example of a cardioid. This happens to be a ladybug right here, and if you see the body of the ladybug, not including the head, just the body, makes the cardioid. Here's another example of a cardioid. This is a dog's face, but we're just looking at the face part right here, not the eyes. So the face part right here, dents in right here, is an example of the cardioid. And then here's the last example of a cardioid right here. This is the peach that sits on top of the tower in Gaffney. This is the cardioid part of that graph. So those are some examples that you can see. They're in the shape of cardioids.